not only one tool, it also with other tools like helm charts and Argo CD, Grafana, Prompt TCS also. Because so learning only Kubernetes is not going to help you in the real-time industry projects. Okay, so with the Kubernetes, what other tools will help you to deploy your project successfully on the stack? So this is what we're going to cover in this program. So workshop. So today workshop agenda is we'll discuss something the history of the Docker, Kubernetes, and Terraform. What are their benefits and the real-time case studies, and at what scenarios which companies are using at what extent. Okay, and then we'll get into some more deeper insights of about this tool. So before that, let me introduce myself. I'm Rajnikanth, working as a DevOps specialist. Okay, so I have extensive 6 years of experience into only cloud and DevOps, complete cloud and DevOps one. Okay, so in the starting of my career, I used to work as a cloud security, and then I used to work now as a cloud and DevOps SecOps, and now I'm working on the ML Ops. Okay. So it's ML Ops again, not ML Ops in different two types. When a ML engineer doing the operational, and also a DevOps engineer will do the operations. So in the perspective of DevOps, I'm doing ML operations. So here I'll be working in this role, and I do have a very good experience of developing product-based products and as well as project-based products and supporting service-based projects. So this kind of experience I hold, and I will be going to guide you in this program extensively, and I will be your mentor. So because this workshop is basically for a program I'm going to start. That one is Docker, Kubernetes, Terraform. I'll just give you one or two lines before we going to start. Docker, Kubernetes, Terraform. So why we are starting this means many students are that took the DevOps courses. Yes, they took, but they're getting only a basic knowledge on the Docker, Kubernetes, Terraform. And after the course, when they are attending the interviews, they're not able to crack the interviews basically. And many of our students also is they got hired into the companies, and when they onboarded into the project, they're seeing first thing first is Docker, Kubernetes, Terraform. So they're just surprising and the feeling like, oh, it is too hard like that. Okay. So this program is designed for that to make you comfortable and easy to configure and make your hands dirty with the deployments, deliveries, and all. Okay. So in this program, I'll be going to teach you in a very easy manner what is a Docker and what is a life cycle and what it is complete in and out. Kubernetes in and out, Terraform in and out. Along with that, what would be the setup of continuous delivery and continuous deployment? How does these tools are going to help in deploying deploying the mono and micro service applications, microservices applications. Okay, because right now in this modern era, everything is microservice. Okay, everything is microservice. So that's why we need to know about it. Deploying a monolithic kind of architectures, microservice kind of architectures, and moreover, even many people are have very good knowledge. I accept, but they are not having what is happening after post activity. Post activity means when an application deployed into production, what are all the things a company will trying to maintain and manage with their resources. Resources are nothing but we are the engineers. Okay, company is hiring us as a resources, so we need to actually drive this one. After post activity means after application deployed into the production, what are all things are going to be involved, like production monitoring, production instance, okay, and production maintenance, production operations. How this is going on in the industry is no one not really taughting you to everyone. So that is what I'm going to cover in this program of doing a deployments with a delivery and continuous deployments, and we'll check about the production level, what would be the KPIs of a company, what KPIs, key performance indicators, a company will follow, and what are all SLI and SLO a company will follow, service level indicators, service level agreements, service level operations a company will follow. Okay, how do we make sure that the application is resilient in the production level? That should be scalable, highly available, and optimizable. Okay, it should be optimized also. And how does it is affecting on the infrastructure? So that's what the Terraform and that's what the Grafana, that's what everything the setup will be going to be on the Kubernetes. We do have other setups as well, container service and Kubernetes service. So we'll discuss those in the program. I'm just giving you high overview of this. You can contact with the admins uh, in inquiry. They'll give you complete roadmap. What is this program is? Okay. So infra level, how it is behaves basically. That is important. How infrastructure will be behave. So is it behaving as expected in the business hours, or how it is doing in non-business hours? Okay, non-business hours. This is also important. How do you going to take all these insights from an infrastructure? Yes, you are going there. You might showing some experience, or you are a fresher. Okay, but you got a very good opportunity like in Accenture. Right now, Accenture is hiring for this kind of roles, and SCA also hiring. So when you are attending the interview, they'll ask this one, hey, what is your approach? So with the minimum knowledge of DevOps, so we couldn't able to answer this all questions. And when they are deploying on this position, it will be going to take a lot of time, and somebody has to be keenly trainers in the industry or in the company. So then only we'll get into on it. So I'm here to avoid these hurdles with this program. So that's why I'm starting from Naresh IT, especially on this. So Docker, Kubernetes, Terraform. Along with it, what are going to be required in it? Okay. So here Argo CD, Helm chart, and continuous deployments with the pipelines. Okay. And monitoring like Grafana, Prometheus, Datadog. Okay. Datadog. So this is the main agenda of this program. Okay, let's dive into some discussion. I hope I have given a very good clarity what is this program and what we are going to be cover. So if not, I can also explain you more. We can have a discussion in the end of the session. So today workshop, this workshop is for I just planned for to make you understand what does a Docker and what does a Kubernetes and what does a Terraform do at our modern DevOps. Right now I'm calling it as modern DevOps. Previously, we used it to handle traditional DevOps. Okay. And we know everything that DevOps is nothing but development and operational. Everyone is saying same thing. Development team, operational team, they do development team will do the coding and operational team will do uh, like operations. So then the combination is DevOps, like this, the general definition but what exactly it is, what happens exactly, okay, and who will be going to be part of this DevOps process. First of all, who will be and who can able to attend my workshop also, means who are the target audience can be attended my uh, program, can attend my program, and you can also go with this knowledge. A software developer and a system engineer and cloud engineer plus DevOps engineer. So right now in this modern era, cloud engineer and DevOps engineer, at some points only we have a cloud engineer separate, but most of the time, like I would say 70% cloud and DevOps combination only. Okay. And data engineer. Okay. So these are the guys who can attend my workshop and get more insights. Even here, a developer plays a very key role writing a Docker file, developing their microservices programs. Okay. And then they are trying to deploy with the continuous integration pipelines, and they are going to be communicate with some of the services on the DevOps like SQS, queuing, message brokering things, okay, and notifications, alerting system. They are generating multiple reports and invoices. In that such cases, they have to go with the SNS things, these things, okay, and other services also they'll be good. Continuous integration pipelines, building them, artifact management. So everything they have to also deal with the DevOps services and tools. Okay. And system engineers who are going to maintain the workstation and as well as cloud workstation, nothing but servers, providing access, maintaining the infrastructure, giving the role-based access controls at the user level, system level, maintaining complete systems to be stable and behave very well. So coming to cloud engineer, who is going to be more into the, I'll say here one more type. One is automation engineer. Okay. Automation engineer is nothing but again going to create a cloud in an automated way with his skill and expertise. Like he might be, he should be very strong at the Python, C Sharp code, AWS CDK, or other Bicep, ARM. We do have other coding languages in terms of automation engineering at the this one. And who are best to be go with this testers. Okay, QA automation testers also, because right now Docker Kubernetes are their future. Even they are doing multiple QA automations for the application, and they are just tearing down everything, and they are just writing every report. Like I would say, they are doing right shift testing. Okay, if any QA automation tester is here, you might better know about right shift testing. Yes, it is best for the Python students also. Like software developer means can be any environment stack developer. It could be a Java, it could be a .NET, it could be a React, it could be a other Perl, Fluent, anything. So tester, QA automation tester, basically they do right shift test. Okay. So what is the right shift testing is nothing but user acceptance testing. And we do have a left shift testing also. Okay. So in this case, where developers, testers are working on some Microsoft services or products, they do a regular deployments. Testers are go and do a regular deployments to test their services. Yes, even they need to be know about the Kubernetes, because now most of 90% Kubernetes in the world. Everything is Kubernetes. And we do have some enhancements also, like serverless architectures like this. Okay. But that is again a separate business mind, which clouds are introducing into the market and grabbing the customers. We'll discuss that as well. But let's jump into the workshop. Okay. Okay. So let's talk about the Docker now. So how many of you know about the Docker? Yes, everyone know about the Docker. Even a developer know, DevOps engineer know, even non-DevOps engineer, a refresher who is doing a Google search, he also know what is Docker. Like he might heard about the name Docker, but what exactly it do, we don't know much actually. Okay, so that is like I'm going to clear you in the way. So we do have a Docker. So with this Docker, we have a lot of benefits in the right now in the market. Okay. So it is for the containerization. It used for the containerization. Okay. Sorry. Containerization, which is going to help you a light application deployments. Okay. A lightweighted application deployments in your environment. So before this, let's understand what is a virtualization. And before that, let's understand how does, okay, how does our engineers are doing the deployments before this virtualization and the Docker. Okay, then we'll understand that why virtualization came into the picture and why a Docker came into the picture. Okay, so let's say I have an application. Okay, so let's say I do like Apple Pay is an application, and I want to here developers are working and as well as testers are working. So when developer is developing any features on this service, let's say this is a one service. So then I'll also going to take a files. Okay, he's developing multiple feature development files. Okay, programs, and he need to test that. So to maintain and to do test, we need to maintain a cluster of servers in the on premises. On premises nothing but data center. Okay, on premises nothing but a data center where a building is will be there, and you will be connecting all servers at one point, and you're connecting all the firewalls, switches, routers, nothing but network connectivities, and you're making available on the internet. Okay, so you're building completely with your private network with the private IP address, and then you're connecting to the external network internet. So here you have all the servers, and here it will be a one more who is nothing but this is a data center, and this is ODC. Let's say ODC means offshore development center, where in Hyderabad, in Bangalore, you're working in the office, right? That office is nothing but offshore development center. And on-site means that is a data center area only nearby. Okay. So here you need to connect through a VPN. Uh, might if you are might working on the Capgemini or Cognizant, most of the customers they have US customers, USA customers, UK customers, Europe customers, Australian customers. Yes, right. Those customers are right now still. a few companies depended still on the data centers, and we used to connect to these data centers by using VDI. Okay, VDI. So like this only. Same way, previous cases, we do need to be connect and do work like this for the onset people, or even it is India also. So here I need to maintain a set of servers. Okay, a set of servers. Let me duplicate them. So these are Linux servers or Windows servers, other Red Hat servers, let's say. Okay. So when a developer is developing these files, he has to check for development separately for this feature, one server. And when he go with another development, okay, he is having another development, another feature in it. So he has to deploy that feature as well into one more separate server, and he has to deploy one more feature into another separate server, and he has to deploy one more separate feature in another server. Okay, so he has to test individual each service in one of the server, and this server is going to have again each server, let's say a 4 GB, one CPU. Same way you are replicating here. Okay, 4 GB, one CPU, 4 GB, one CPU, 4 GB, one CPU. Okay, 16 GB and 4 CPUs you are taking here. So why can't you go for one server and you can test the things by maintaining an isolation, by maintaining the isolation. So this kind of structure was there, and this is hard to maintain the servers, and hard to maintain the network, and hard to maintain the compute resources. Compute resources nothing but CPU and memory of a server, a bare metal server. Okay, so this is going to be a very like a risk point to a company, any company, whenever they go for development and testing. So they are maintaining this kind of cluster, two or three, for development, staging, and production, and everything is manual. They work with the waterfall method previously. Okay, and then they came into the agile methodology. Even when agile methodology is there, also some companies still following this procedure, still following some procedures here, because they are holding very legacy applications. So we don't want this kind of a highly risky environment where it is taking a multiple uh, like it's taking much time and maintenance thing. So we don't want like this. Yes, you can see this video on the YouTube in the live. Okay. So who are going to maintain this one? So we do have a system administrator or Linux administrators who are going to maintain this servers, and very big hurdles to them basically. So after this, we came with a virtualization. So what a virtualization do here? So let me remove this. What a virtualization do here? So I'll be going to take a one server. So in this server, I'll going to install one operating system. Okay. So this is nothing but main operating system. And then after, on top of it, I'll be enabling virtualization, which is nothing but VM. Okay. Virtualization. And on top of it, I'll be going to create an isolated environments. So that means when I'm taking this server is having, let's say, 16 GB. and 4 CPU. Okay, so this 16 GB and 4 CPU I need to distribute to this the logical VMs also. So these are nothing but logical VMs. So inside this logical VM, what you have to do? You have to again go for an operating system. You have to again go for a guest operating system. Let me down this. You have to go for a guest operating system like this. On top of this, you can do your application deployments. Nothing but you can do your application deployment and you can do test here. Here, okay. So you have to distribute this resource constraints to this logical VMs also. But where your logical VMs also need a guest operating system. On top of it, you're going to do your application testing. But it is at where it is at a single server, you're enabling the virtualization. Okay. So it is nothing but again hypervisor also. There's no much difference between hypervisor and hypervisor. You might heard about this word hypervisor and virtualization. Both are same. It's a technology of enabling the virtualization. So hypervisor is the previous one, and in the modern now we came with the word virtualization. Okay, we do have a types also. So this is a VM. Here I need to do a application testing. But when you're doing this, connecting these interfaces are somewhat complex. Like you have to connect interfaces with this guest logical VMs, and you need to enable internet connectivity for this. And a developer there, and the developer is doing an active deployments here. Today is fine. Tomorrow also is doing active deployments here. Fine. And day after tomorrow also is doing active deployments. And this is having 2 GB or 3 GB. Let's say, let me take this one. So it is having 3 GB, and 3 GB is consumed already. 3 GB is consumed, and developer wants to deploy more files into it. Is, let's say, is doing a React.js application testing. When he's installing node modules are needed, node modules are creating more. It is utilizing the more space in it because we need to deploy npx, npm, and everything. It is taking a more usage, and but the application is not successfully running, and still he want to do something and is installing more dependencies. Automatically it is going to fulfill this or it is going to reach the limit of the 3 GB. What do? You have to again increase this one, right? To increase this one, you have to again attach an extra value, right? And then you have to attach to this a particular hypervisor V to be read this value, and then you can do your deployments. So this is going to be a system administrator headache. They are facing a lot of headache while this kind of a configuration, and also they use it to maintain monitor from the vSphere and vSphere tools. Okay, for centralized managing service. Like there are a lot of things they are facing issues. So this is with the virtualization. So what exactly here make me to go for a Docker? That means, so here you are dealing with the guest operating system first thing, and you have to configure this manually, and you have to always ensure that connectivity should be there from your physical base operating system, your logical operating system here. Okay, and this should be followed a separate network identifier where you can browse and do your testing of an application, right? And if you have a set of servers like this, other set of servers, you need to maintain it as a cluster collection of servers. So this much big problem was there here, and it is not lightweight. Okay, it's not lightweighted. For example, here my application is running successfully, and this same code files I want to move to this server. It's not possible here. I want to move to this server from here to here. So it is not a lightweighted and it is not that easy to be move here. So this application files into another server from your virtualization. But there are technologies enhancing and VMware came and now we have VMware cloud also where it is having all this kind of features but still not lightweight. Okay, but still it is not lightweight. So we do have other alternatives of doing enabling the virtualization and doing the containerization things basically. So what are they? We have this one. Let me write down that. We do have Podman. We do have Builder and LXD and LXC and RunC. Okay, so these are the and build kit also. Okay, so these are the popular solutions a part of your Docker. Okay, for you to maintain a virtualization and for consistent scalability and doing containerization also. Okay, so these are the other alternatives we do have. But why only I need to go for a Docker over this kind of disadvantage or this kind of disadvantage? Okay, so let's discuss something about the types. I think I provided a notes. Let me open for you all. Yeah, and one more thing. This kind of issues we are facing at 2008, especially at that time. At LXC and the kernel was introduced and it come with one new technology as a platform as a service that is .cloud. Okay, platform as a service .cloud, which they came and did a standardization on improving the container technology. From there, many things are inspired and did enhancements on the containerization .cloud. Okay, .cloud is a platform as a service company which they did more enhancements on the container. Okay, yeah. So let me open a notes. Then we'll dig into the lab. Okay. So if you see, we have a benefits about the Docker. It's a consistent environment, scalability, portability, isolation. Okay. And when I come to the use cases, it's have a microservices architecture, best for microservices and dev and test environments, basically. And then after you can go for production by mimicking the same thing. A real-time case study, if you see, uh, we do have needed a scale service quickly to meet the user demand at Spotify application. Solution like use the Docker containerized services, allowing a rapid scaling and deployment. Result which is going to enhance the deployment types and more efficient usage. Okay, so this is going to be done with the Docker only, which is a real use case I took from this company only. Okay, this one from you can read out with the multiple articles. This article was already released on the Spotify. You can check it out. Okay, so coming to the types of the hypervisor. Let me come here. You can see the difference between the virtual machines and the containerization. So what I said, it is exactly the previous cases, previous generation, which are the engineers are doing. Now, if you can see, we have a types of hypervisor. Type 1, which is nothing but bare metal, runs on directly host hardware, okay, and manage the guest operating system. Example, ESXi, hypervisor, and Xgen. Okay. And type 2, which is nothing but hosted, run on conventional operating system as a process, relying on the host OS hardware management. And example, VMware Workstation, Oracle, VirtualBox, and parallel desktop. We do have a application, parallel desktop also. Okay, which is going to maintain a separate isolation on the your virtualization, and which will give you to do your stimulate your or evaluate your testings and developments on it. Okay. So coming to our main drawbacks, require more system resources due to need of run full operating system. VM having a longer boot time compared with the containers. It's a complexity to maintain. But whereas containers, let me go for a container diagram. So this is a base, guys. That's when I'm taking this much of time to explain you this one. This is the base. After this only, whatever our infrastructure is going to be, uh, like we create for these things only. We are setting up Kubernetes cluster. We are setting up Terraform. We are setting up everything for what? For an application. But application we are doing is containerized. First thing we are doing application to a containerized application. Let me tell you. So this is an application. So this application we are doing as a containerized application. Okay, containerized application. So converting this process is very, very important. First thing, because it is a lightweighted application, easy to move, easy to maintain the resources, and it will save a lot of money to a company. First thing, it will save a lot of money to a company. So every application right now you're seeing everything is containerized application. 90% containerized application. Other 10-20% are with other technology. We are doing a deployments at the production levels, but so we do a 80%, 90% with the containerized application. So okay. So then how does the Docker here? Yes, I'll be having the same operating system. On top of this, so I'll call it as base operating system. Okay. On top of this, I'll be going to run a Docker. On top of this, I can run multiple containers. Now this is a container. Container again, nothing but running virtual instance of your application. Running virtual instance of your application. Inside this container, you will be running a application that is running from an image. Okay. It is running from an image. It's running for image. Image is nothing but again, it's a executable binaries and libraries and packages and config files with environment variables. Environment variables. Image is nothing but, so it is a one format which have everything yet in one specific package. I'm calling it as a package. So executable binaries, libraries, packages, config files, and environment variables in it. So this is going to be run as a container. This image is going to run as a container. So here to convert this image, we need to follow Docker. We need to follow Docker. And from this image, we need to run it as a container. Then we have to follow the Docker process. So when my container is running here, it is nothing but a server only, nothing but logical server, not a physical, logical server. So inside this logical server, my container will run and I can able to access this container through the internet. And you no need to maintain any base operating system. Hardly it is going to take how much? 200 MB, 300 MB, hardly 500 MB. If you're running a big application, it's going to take like 1 GB. That's it. Not more than that. It's a lightweighted, and you are maintaining the images, so you can easy to move to another server. You can run the container in another server easily. Very easily you can run in another server. Okay. So you're maintaining and deploying and running in a high, faster mode is easy with the Docker. Very, very easy with the Docker, especially for microservices. Even for the monolithic, we have to set up one container only for whole the solution. But coming to microservices, we are going to keep each service as one container. Okay, as one container. So that's why right now everyone is on this Docker containerization. It's a very, very easy. So let's come into my instance. I already have an instance here. Let me connect to the instance. So which I already installed Docker. So I do have a code here. Like these are nothing but microservices codes. Microservices codes only. Like we have a payment order, full stack e-commerce, registration, e-commerce restaurants. So if you can see one of the, let me go to e-commerce restaurant, LS. I have a front end and a back end codes here. Okay. So here itself, the microservices, it is developed in the React.js and Node.js. It is on the Node.js basically. And if I go to the front end, ILS, then these are my files. And I do maintaining the Docker file here. Okay. So this is my code and I want to create an image. I'm not having any image right now. Okay. I'm like, Bilkul, I'm not having any image here. So I want to create an image from front end and I want to create an image for back end, and both should be communicated. Okay. So I do have one file which is called Docker Compose, which it do automatic deploying the containers and building the images. Okay. So let's me do Docker Compose. Docker Compose is nothing but which help you to build the applications, so nothing but your containers in a one go without running multiple commands for each thing. If not a Docker Compose, what you have to do? You have to build an image with sudo docker build -t which is tag name and Docker file path or dot, and then once you are building the image and you have to run docker run command and -name of the container and port forwarding -p like this, right? I think most of the people are already took the DevOps, then they know what is this command. So with this, we're going to run as a container. Then I can able to see my container is running or not. Then I will access that. But Docker Compose will help you that don't run these commands or don't fire these commands. You can just run one file which is compose file. Okay. So Docker Compose up, I'll say. So which is going to build all images and containers in just one go. So let it run this one. It is going to build the applications and it is going to run the containers as well. So meantime, I would like to create the Kubernetes cluster also, and I want to show. So have a please little like more of an hour. Please have a patience and be on the session. So then you'll get to know a good subject. Okay, let this run. Now it is, first of all, I would like to tell you one thing. See, any development area, any developer, first they'll do a development on the back end, then they go for the front end. As a DevOps engineer, you are also deploying first back end and then you go for the front ends. First, backend system should be ready and sufficient, and then we go for the front end to be deployed at the industry levels. So all the way when you're going for deployment process, the process will be like this. Okay, so what I'll do, let me take one more one. I do have a Terraform and I would like to create a Kubernetes cluster in my cloud. Okay, so in my cloud, I would like to create that. So let me go to AKS. I'm just directly using the managed Kubernetes service. We do have a standard Kubernetes service also, but I don't want to be there. I want to be with the managed Kubernetes service for this workshop. Right now, I'm not having any EKS cluster here. I would like to create through Terraform. And before we going to create the cluster, and let me give you some info about it. What is Kubernetes? Okay, what is a Kubernetes? Let me open this one. Yeah. So I'm doing a container here, right? This container need to be orchestrated. This container need to be orchestrated. Orchestrated means it has to maintain, self-heal, scalable, and it has to perform in at resilient. Okay, it should be reliable. Basically, I would say it should be reliable and scalable, flexible, and it has to be restart or it has to be have a rehealing process when it is getting some trouble. So who is going to do this? So we have a orchestration technologies, which is from Kubernetes. So it is from the Google, basically. In the first of the Google Borg only, right? Yes. So he developed this kind of orchestration, highly. Uh, Let me go and search for it instead of having the confusions. Borg. So he has created from the Google side. He has created a very good cluster management and orchestrating things on the orchestration sites. But later on, enhancements are needed, and then Google has given developed as a Kubernetes, and they're given to the CNCF. Okay, Cloud Native Services, and from there, the birth of Kubernetes is in the 2014. Okay, and it was still at the POCs at 15, and it is into the implementation and practice from the 2016, and at 17 it is boom from 17, and from 18 like the jobs hiring is done on the Kubernetes. Hiring is started. Okay, if somebody telling you I'm having 10 years of experience on the Kubernetes, no, first Kubernetes started at the 2016 itself and implementing from 2016 ending onwards. And how does the candidate is having a Kubernetes 10 years of experience? Okay, that is completely wrong. So this is how, and even DevOps also. Okay, DevOps is from the 2015 itself on. We're not following this kind of a traditional like method before 2015. 2015, nobody, not even know the kind of DevOps word properly. And now people are saying that I'm having 20 years experience, holding 15 years experience on DevOps, 12 years experience. I don't think even they have total IT experience. But coming to DevOps, they might be having six, seven. Seven is last as calculated now. Okay. So like this. Google is we have, and we do have other alternatives for to maintaining this. We do have Docker Swarm for maintaining containerization. We have OpenShift, and we do have a Rancher, and we have a CubeWatch. We have other Portnainer. These many alternatives we have, but among all of this, OpenShift and Kubernetes best. Right now, like in the market, Ranch are also doing some kind of play. Like it is also playing very good things. Rancher for maintaining the Kubernetes clusters and doing the orchestration. Rancher. Rancher also one tool, okay, for orchestration. It is also a very good, like many companies are using right now. I would say like that's Bank, American Bank, banks are also using this one. So knowing Rancher also a good thing. I'll be give you a good overview on it also in this program, but I'll be not covering all this in deep. I'll be covering focusing on Grafana thing and monitoring and post activities thing. But now, oh, I want to create the cluster first. I am just getting into the discussion. So I have already a code with the Terraform. Okay, so let me come here. So I have a code with Terraform right now. And what is a Terraform? We know already Terraform is infrastructure as a code, which help us to write and create or provision the resources over the cloud, right? But why you have to go for a Terraform? Why you have to go for Terraform? We have other tools as well, like we have JSON and CDK, and we do have a CloudFormation. We do have a this one uh, like Pulumi, and we do have a I forgot ARM template. Okay, so we do have this many, but why I should go for Terraform itself? Because Terraform is easy to write and completely declare it. Okay, we'll be going to discuss of each block in this program. Okay, and how this block is taken in Terraform, and why it is maintaining the state management, and how does the state is creating, and what is a sync state and desired state, and how does this resources blocks sources and everything we are going to take and putting in a sequence manner. Okay, so first thing first, Terraform is helping me not to huddle in the GUI. It's telling that don't huddle or don't face anything at the graphical user interface. It is the biggest like time taking process for you when you want to create a big infrastructure at wide range. So I'll be helping with the Terraform script. You can just write, this is from the HCL language only. Okay, so I'm going to help you in the HCL language to write these all blocks. I define all the blocks. You can come and put it in a sequence manner. We're not doing scripting. It's just putting every block in a sequence manner, and we are editing our values and parameters. Everything is available already on the internet. We don't need to think much about it. Hey, I need to write this or I need to develop this code. Everything is on the internet. Everything is from Terraform registry. We don't need to take that much headache in our brain. Everything is there. Even in the companies, even I do. Everyone do. Any big senior resource. Everyone is look for the registry only. From there only they will take and they'll do development by changing the parameters. It's not something that I need to write without knowing this. I need to develop the code for this. No, you're just using the sequence and the logic here to provision faster resources on the cloud. Okay. So I would like to open a terminal here. What is my path? Desktop and DevOps. Let me do Terraform init here. Oh, it's not recognizing. Then I should go hit my terminal. I need to configure environment variable. Seems. So let me go back and let me go back to the desktop and what I have ls. Yes, here I have Terraform scripts. I'll be clearing this. Terraform init, which is going to initialize my plugin, the backend, the local repository. Yes, Terraform plan. I'll directly go for a plan. So it is giving me green color marks. That means it is going to create how many resources? I think almost all it is going to create 11 resources, which is going to create cluster, node pool group, and IAM role. Okay, for node pool group and internet gateways, route table association, subnets, two subnets, VPC. All this it is going to create load balancers and all. Now let me go for Terraform apply, which is going to create my resource. I should run FN up. Okay, so, okay. It's running already. So I need to give S value. Then it is going to create my resources over the cloud. So if you come to the EKS cluster, so we're not having any cluster. In just a minute, you're going to see the cluster here. See, automatically coming. And when I go to EC2 instances, here I need to see two more instances for my Kubernetes cluster. Okay. For my Kubernetes cluster, I need to see two more instances. Here I am having only one instance. And we are doing a deployment with the Docker, right? Let's check it out, that one. Where is that? So here it is. It's already running, see, back end, front end things. It's already running here, like e-commerce. Let me go and check it out. What is the IP address of this one? IP address. Since it is Node.js, it works on 3000 port number. Yep, it's open. Login. Uh, Let me say something. Login successful. Should sign up. To do sign up, upload the image. Like you can go downloads and uploading image and just type something here. Sign up. Oh, it is not signing up. If it is not signing up in the sense it it have some issue with my MongoDB. My database is not thing I have connected already. I think forgot. I think I have to maintain that cluster. I think I have to pay for it. Okay, okay. So let me try one more code here. We do have other one. No worries. I'm just stopping right now. You can see direct stopping control C. It is going to stop all your containers here. Yes. If you can see Docker images, you do have a Docker images, but I don't want these things. So I want to delete all this. So we can use Docker system prune, which is going to clear everything in my Docker. Okay. So then see it is again claimed the 37.23 MB. So let me go with another one. Like I'll come back. I do have payments order full stack e-commerce. Let's go with that. I have here front end and back end Docker Compose, Docker hyphen compose up or build up. You can give both the commands build hyphen up or Docker Compose up. Both thing it do. Basically, it is doing everything at my container. You know, it is pulling the container inside the container, running virtual instance. So this is my VM right now. This is easy to instance, but I'm not worrying about my the base operating system. I'm just it is very lightweighted. Oh, it's having a error. It is because of the okay Docker images. Still, we have a Docker images. So let me. I think it is the space is not enough. Or let me go with Docker rm hyphen f dollar Docker ps. Oh, sorry, Docker images hyphen a hyphen q. Close this. Which is going to. Okay, I need to remove the first containers. There are hiding containers and running containers. So I think Docker ps hyphen a no container. That's why. Now let me delete all the images. RMI. I have to use yes Docker images. Now if you type, so there is no image. And let me also give to be clean a prune. Now it's gone and it see it's claimed again this much. Now I'll going to run Docker Compose up. I hope it will not going to give us an error. And meanwhile, let's check our this one cluster creation. The cluster is created, but it's creating node pull group. If you come to EKS, see the cluster is created here. And if you go here, so it's trying to create a compute here node groups creating. I should able to see nodes, two nodes. If you hold for more few minutes, then we'll jump into the cluster and we'll do a deployment, guys. See, setting up the CD environments is going to take time. It is skill. When you set up your own, you'll enjoy if you have a good knowledge. It's running and my cluster also creating, right? Yes, my cluster is done now. Okay. So I just want to authenticate this one. I already installed kubectl here. Uh, get nodes. See, here it is telling that you are not able to connect with your current API group. Nothing but Cube API. Okay. So when you are not able to connect with your Cube API, so what you have to do, you have to authenticate with the Cube API. Okay. So for that, you can run the command like AWS EKS update hyphen cube config hyphen name. What is our cluster name? Cluster name is EKS demo, and then hyphen region AP South -1. Okay. Yes, it's updated now. You can see it is created a kube config. So here in this folder, then it is holding the information about the context cluster. We say it is context cluster. So if I go into the same path, so where it is, if I go into the same path, users Rajni dot cube. Okay, this one users dot cube. You can see this one. If I am going to open in a notepad, open with a notepad just once. See, this is the information it holds. This is kube config. API version, a cluster, contexts. Context is a very important in terms of your namespace and selecting the clusters and authenticating at your organizations. Okay, you'll be having multiple clusters. So we have to be authenticated properly to the one of that. So you make sure you have to install kubectl and EKSCTL in your system. Okay, everything we do from the terminal itself only, guys. We don't use mobile extremes. We don't use any putties at organization. Mobile extreme, I'm telling everyone, stop using mobile extreme. That is not going to help you. That is something like a training institute only for student you to practice and first habituate to the terminal. But at organization now, everything, all the things you have to configure from the terminal. AWS CLI, Azure CLI, GCP CLI, they are giving the CLI and cloud shells. Why you have to go for third-party tool? Third-party tools are not allowed at the organization. Okay, we have to do from itself from our terminal. So this is my CMD. Here I have enabled the git bash. So you can go for PowerShell or command prompt. Here we will do the things. Command prompt itself will give you all the features. So what is the advanced feature that mobile is providing? Okay, so stop using it. Why? I'll tell you one big reason why I'm telling you stop that. Okay, for example, so this is my last session. Okay, with my EC2 instance, I think. Okay, see, I'm having the log here. I'm having this much log. This much log I'm having. Log in the sense, I just connected to this instance right now. Oh, it got failed. I just connected to this instance right now. If I exit from here, if I exit from here, and I got an error actually here above, and I exited. But while I'm again logging into the instance, it is not showing me. It is not connecting. Without connecting that, then how can I know, how can I take the log? Say it, is it possible in the mobile extreme? No, you won't see the log at the dump. But here you see, I disconnected from the server. But above I have a log. Above I have a log what I have did. All these things you can see. So for this purpose, you can go with the CMD. huh? Like I've seen many students that why they're using this one. So we have to log in through the CLI by using AWS configure, and we have to provide access key and secret key here. Okay. So this access key and secret key will be like this. Okay. It will be like this. And you have to create that from going into the security credentials access. Here you have to create it. Okay. Right side, your account, go to security credentials. Come down. Here you have to create access keys. So this access key, secret key, you have to provide in the terminal here. Okay, then you will able to log into that. Unfortunately, it is exiting because the front end exporting image exporting layer. Let's also write the Docker over there. And, no space left on the device. I think it's already consumed by the last deployment, I think. Okay, no worries. We do the same Microsoft deployments at the Kubernetes also. Um, let's say here, as I said, authenticated, right? kubectl get nodes. See, it is showing me two nodes here. It is showing me two nodes here. And I would like to deploy a microservices application here. Okay. So for that, I would like to open a code with my VS Code file, uh, open a folder like at the desktop, downloads. Okay. So I have this all already, like just before I said, right, containerizing and developing the things. So I have manifest file here for each of the one service. Okay. And let me go for ingress control here. What I have given, I have given a site as shop.zapto.com. Okay. Okay. So what I do, I'll be going to create one new DNS. Let me go for it. So I'll be going to take a new DNS, which is no host IP DNS. I'll be going to log in with my, it's asking Gmail. Which Gmail I have? Let me sign up. Free sign. Uh, this is I'm not having the Gmail account here, but let me try to do with this. Create a new account. I don't want right now to be created. Um, okay, let's take this one. Right. I'll try to take a temp mail. So later we go for a DNS configuration. First, let's do a deployment. Then it will save our time. So right now I have this one. So I have deployments say like an ingress controllers and services and all the things here. So I'll be going to just apply this one to my Kubernetes cluster. I'll be just enabling the new terminal here. Okay. So all the images by using Docker, I already uploaded into my Docker Hub. From there, it is calling the image. From there, it is calling the image like, okay. So image, here, see, Redis Alpine, and we do have other images. Okay. So this is the shipping services thing. So let me go for and apply these things. So I'm in online boutique website. Yes, right. You CTL apply hyphen F Kubernetes manifest.ym. I'm going to apply this and I'll keep the watch method here. Okay. kubectl kubectl get pods hyphen watch method. Okay. So now it is not showing any pods. So let me apply this one. Okay. So here it is not recognizing my terminal. What I'll do, I'll switch to a bash. kubectl is not found here. So let me go to the same path here. I have to come back and I have to go to downloads. Downloads. Here I have to go for online project. kubectl apply hyphen f dot. Now if you can see, now I can keep the watch mode now. I'll be keeping the watch mode of kubectl get pods, SVC, deployments, and ingress. So these many sources are not taking. Then I'll going to keep SVCs only. Watch mode is not taking two services. Let's take one watch mode. Almost all are ready. Only two are not ready. See, each service is a repository. Each service is a repository. Each service is a repository. Each repository you have to write a Docker file. For each repository you have to write a CSCD, and each one you have to deploy. Okay. So all these images I already developed and kept at my Docker Hub. That's why I'm directly calling here to save the time. But for this service, we need to maintain a separate repository. This is what the microservice. Legacy means monolithic means we'll keep everything at one repository. But coming to microservice, we'll keep everything separately. Okay. So let me check the pods now. Pods, all the pods might already all running. And let me check this SVCs. Now, if you can see SVC, all the services are from cluster IP except one. Which one? Front end. Except one. Which one? Front end. It will be like this. So let me draw a diagram so you'll get a clarity. So how it is happening? I have a nodes here. Oh, it's too slow, guys. Wait a minute. These two nodes here, and I'm running pods, right? Cart service, order service, address service, user service, like this. Everything is a one service. And I do have a front end. You should be follow UI, right? And all these are exposed with the cluster IP to secure them backend services. We backend services we should not be exposed on the load balancer. We should not be exposed on the node port or public side. We should keep it as private as with the cluster IP. Okay, one service will going to be do as a front end, which is UI. Okay, as a UI. So I'll say it is an ingress controller first. Ingress controller. And when a user come, it comes to the ingress controller. Okay. When a user come, it comes to the ingress controller, and we will be having the UI pod first. It's a UI pod, which is nothing but for front end pod. And from here, where you entered into the website and then you are clicking on orders, then you'll go for orders pod. And when you click on service pod, you'll go for service pod. When you click on something other cart pod, you'll go for a cart. When you click on order, you go for a order. When you click on something like a checkout payment, you go for a payment. This is how you will be directed. Okay. This is called path based routing. This is called path where you do from ingress controller you do. Okay. So let's see that. Now if you come here, I have a load balancer, only one thing which I'm exposing publicly. Copy this and come here. I'll just paste here. Since it is application load balancer, it is going to take some little amount of latency because it was on the layer 7. So it is going to take some time, but now it's see it came. Now this is a website, and here I have all the services. How many services we have? We have a ad service, cart service, checkout service, currency service, okay, email service, front end service, okay, payment service, product category service, recommendation service, Redis card, shipping. So here, if I going to select one product and I would like to add the number of products to, then add cart. It come to the shipping address. This is also one repository. This is one service. Okay, and I want to add to cart before going for a placing order. I want to add cart. Okay, so we are already doing right add cart. See, when I go back here, this is my basically a DNS, which is application load balancer DNS. Okay. So this DNS you can map with the DNS www.something.com. I just want to create that. Uh, let me do that. 1 minute then. Sign up with the Google. It's not coming. I'm not having a Gmail address here. That's the problem. I'm not having a much Gmail address. Okay, for dynamic DNS, this site is not going to do that. Anyone have your Gmail address, please? A spare Gmail address. Just give me on the chat. It's just going to take your sign in. That's it. Hmm? Can anyone help me with your spare Gmail address? Thank you. And then you can change your password after this one. Anil, I took your one. Change it as soon as possible after this session over. Can you give me your password as no? Can't see message from you. Someone please give me your password and mail. Okay, I got it. Sorry to trouble you on this, but can you just do it 83? One more 99. Thank you. NoIP.com. Here you can get IP also. NoIP.com is there's no IP not like that. So I would like to create one thing. Which one? So what I'll say, I'll be going to create one uh, like one DNS, my service DNS record. I'll create a DNS now. Add a host name. The host name will be what we have kept at the here. So we kept as a DNS name as this one, ingress controller. Okay, and then I'll come here and I'll remove this one, zapto.org. So I'll going to take it as CNAME. When you're going to take it as a name, you have to update the this IP address, but I'll going to take the CNAME. Here you have to give a dynamic DNS, which is our load balancer. Add host. Already this should another hostname domain. I'll just add as a one. Now it's created. This is my DNS available. If I copy this and I paste here, I should able to open my website now. So I need to check this one first. Is it giving any? Yes, it's open directly. You can see. So one Zapto.org. Now this is my site. See, whenever you click on some shoes, here the URL will going to change. That's what your English controller do the path-based routing. I clicked on it. It came to product and this one, and I'm selecting three carts. It is added into the cart service where it is going for cart part, and then I'm going to go for empty cart. See, it is again back the routing, and now I'll go and adding one more product came. and I'm adding to cart. So it has added the cart, and now I'll go to place order. Okay, it came to cart and checkout part. Checkout is a one part, cart is a one part. One container. This is also one container. This is front end one container, cart one container, checkout one container. And with three container, the communication is happening. Okay, and continue shopping. Yes, again I come back. So I'll go for a cart. There's nothing is there. I'll select one loafer, add to cart, and I would like to place an order now. So this is the information I have here. So what I'll do, I'll place the order. Your order is completed. Okay. So like this. So this is how we do Microsoft deployments and developments. We do this kind of websites in our program more in deeper, how we can develop this and how we can deploy this, all these things. Okay. You can see this. This is how it will be going to do a path-based routing at the Kubernetes. So this kind of applications will be going to deploy in deeper, understanding in deeper, and we'll see after post deployment how does Kubernetes and pod going to be behaved and all, and we'll get to know more into it end to end. So that's what I just want to give you a demo on it. So how the program will be, it is too technical and too deep inside. So her like after this program, you're easily able to crack an interview in just like very easy. So if someone is sitting in front of you interviewer, you'll show your profile is very at high end. Okay. Now I am open for questions and answers. So the course content will be you can have a contact with the admin. So admin will share you the course content and the duration. Duration is going to be a more 45 to 50 days. Sure. To cover all this, we have to take this time. And I'll be providing you notes like this. Okay. And from Notion, a very clear Notion with all your like, it's high-end answers. Yes, 45 days. Yes, I'll be going to run end-to-end pipeline as well. See, doing a deployment, then we have to run the pipeline. So I'll be taking you the pipeline sections from GitHub, Actions, and GitLab, CSC. Okay, modern DevOps. You'll get this video on the YouTube. In I think in next 1 hour, have this workshop video. I prefer GitHub Actions and GitLab. Okay, Jenkins. I'll tell you why. Jenkins, you already learned it. However, at the DevOps course, right? So Naresh IT YouTube channel. At Naresh IT YouTube channel, you'll get this. For continuous deployment and continuous delivery, we do continuous deployments right now. Okay. So with that, we have to go with the GitHub Actions and GitLab. We have advanced tools here. Still, people are stucking at Jenkins on. It's from Monday, from 12th in morning 7:30. Let me write down that 7:30 a.m. IST. Naresh IT KPHP. Okay, and it's going to be a 1.5 hour session every day. So we'll be jumping inside deeper, sequence wise. Okay, sequence wise. Trust me, I'll take you in a sequence wise, and I'll make you a 3 4 years guy, experienced guy in this special program. So this is too advanced one basically, and I'll tell you how you can utilize your own knowledge for the self learning also after this. So that is going to help you at organization. No one will not hurt you. So here we have a good institute like Naresh IT. There we have a good trainers. But at organizations, they'll give you tasks. They are paying to you, right? They'll ask you to do. It's from 12th June. Okay. It's from 12th June. So you can take this link. See, I can't give you a direct days. A Kubernetes take only 10 days. Docker take 10 days. Docker, however, take 10 or 10 days. Within 10 days it's going to complete. But Kubernetes is not going to take 10 days. Terraform not going to take 10 days. It take more days because we have a lot of modules in it, of submodules in it. We need to go with each topic, which industries are using right now. You might know about Terraform init apply command. There's some blocks only, but no, a very good subject there inside. Organization industries are use that. They'll ask if you attending an interview, they'll screw up with the scenario. Okay, those kind of scenarios things we'll do at our program. See, Terraform Cloud is a licensed and enterprise version. Okay, when you want to maintain any workspaces or like that. But for only normal provisioning, who stops you to not to use the Terraform? Okay, if you are on the Azure, is you are feeling like that, you can go for ARM. If you are on the AWS, you're feeling like that, you can go with the AWS CDK, which is high advanced one than the Terraform, especially for proprietary of the AWS. Okay, AWS CDK. If not, Terraform is good. It's a declarative and it maintains the desired state. State management. State management is an important thing. When you have a wide range of project at like many resources, a big infrastructure, Terraform is the best. And right now, there one more tool is coming into the market, competition to the Terraform, which is Pulumi with the Python based. This one. In coming future, this is also going to be a advanced tool in the DevOps. Okay. So please, anyone like developer, system engineer, cloud engineer, Linux administrator, network. Oh, I forgot to mention network administrators. If a network administrator wants to switch inside a DevOps path, inside your organization, you might have already DevOps team where they use OpenStack. Okay, so get connect with them and see that how they are doing with OpenStack and OpenShift and learn over there and get good knowledge and skill, then switch to the DevOps side. Others like Linux administrators is the base for the DevOps. Cloud engineers, data engineering. Data engineering also will do. Okay, they have to maintain multiple jobs for data ingestion, data transmission, data flows for doing maintaining all this. Like and who are DBS, data engineering, nothing but DBS and ETL team, ETL guys also, and software developers, cloud engineer, DevOps, automation testers. For network engineers, already companies are hiring DevOps at a huge manner. Okay, like AT&T, Verizon, other like KPN, and we do have other telecom-based companies which they are hiring for DevOps who knows the network. Okay, so you need to learn the OpenShift, Kubernetes, like key. Without this, the telecom based companies project right now are they not running their applications and the framework works. You have to know the Kubernetes and OpenShift and OpenStack also. Okay, let me go for deletion of this my things. Any questions still? So I can wind up. Already I took extra time of yours, everyone. I'm happy that you are maintaining like you have all patient and uh, in the session with me. Like you listen whatever I said. I'm sorry if I'm boring you at some theory, but without telling a theory, if I go for practical, it doesn't make sense. I'm a more practical guy. In my classes, you'll see more practicals rather than the theory. Okay then. So if no questions, I can't see any messages more. So thank you all. Thank you very much for joining the session and becoming successful this workshop. So don't waste time. Get into it because the market is up in the India. Learn it. Get into the jobs. Thank you, everyone. Okay, let me terminate this one.